this question, you are given a circle with the center FC. It has got a radius of 10 units, and it also has a tangent to it. That's PTR is a tangent, and you have a point R on the tangent, okay, where the x value is k, the y value is 21, okay, and then you are also told that the x-axis here is parallel to the line PS, and PS is a tangent to the circle as well. Okay, so if you did the question, you can just mark your way as I go over it. Okay, as I go over the question, and it's not a good thing to not do your homework at this stage. And I think I told you that because you are in matric now, you can't go to bed early because things are not normal for you. Okay? Yes. I never said you should not sleep. Go to bed, but you must go to bed after finishing your work. Okay? Alright. 4.1 says give a reason why TC is perpendicular to TR. So TC is from here. TC is this line here, from this point to the center. So it's from the circumference to the center, that's TC. And we have got the tangent TR. Okay? So the reason that you must give here is based on circle geometry grade 11. Okay? Why is TC perpendicular to TR? It's because a radius and a tangent are perpendicular to each other at the point of contact. So you can give the reason as because of tan perpendicular to radius. You can also give the reason as tan perpendicular to diameter. It can be acceptable. Yes. Yeah, it's fine. Okay. But the reason is based on circle geometry is because TR is a tangent and TC is a radius. A radius and a tangent are perpendicular to each other at the point of contact. Then 4.2, calculate the length of RC. Now RC is the length from the center to from here to there. Okay? That's RC. Now to calculate RC, it's very easy here because from 4.1, if TC is perpendicular to TR, means this angle is 90. Therefore, triangle CTR is a right angle triangle. And RC will be the hypotenuse. Do you all see that? Yeah. Therefore, we have to use the theorem of Pythagoras. So, we say in triangle CRT, okay, if I use the theorem of Pythagoras, it will be RC squared is equal to TC squared plus TR squared. And then you write Pythagoras here. Okay? Now, if you look at the mark allocation is 2 marks, there is a possibility that since this is analytical geometry, there might not be a mark for the reason for theorem of Pythagoras, or it can be combined together with the statement. Okay, so with our RC squared, our TC is 10 units, and TR is 20. So you get 100 plus 400, and that will give you 500. That's RC squared. Then you take the square root, that will be the square root of 500. You simplify that, okay, you can have 25 times 20. So you can end up having 10 square root of what? 5. Right? Units. And if you didn't write units, it's fine. Generally, you should write what they're talking about distance. So this is what you're supposed to have done. So obviously, there's 1 mark for the answer. The other mark will be probably the use of the theorem of Pythagoras together with the reason. So we must write the reason there. Okay, if it happens that the reason is not allocated a mark, it's fine. But the use of theorem of Pythagoras is important. And also maybe the substitution is all combined with the theorem of Pythagoras. So this was the first part of the question. Okay, so it's not complicated. In actual fact, 4.1 is grade 11, 4.2, it has got some grade 8, 9, and 10 into it. It's It's not very complicated. Okay, can I move on now? All right, the next question says calculate the value of K if R lies in the first quadrant. So you can see that point R is in the first quadrant. Okay, so we're going to calculate it. Now to calculate it, we don't know the equation of the tangent. Okay, we don't know the equation of RC. So my suggestion, use the distance formula. Fortunately, we know the length of RC, okay, from the previous question. So we're going to use the distance formula because if we use the distance formula, we have got three values that we know. We have got, say, this is x2, that's y2, then we have y1, then we don't have x1. So I'll just use the distance formula. So I'll say RC squared is equal to y2, sorry, x2 rather, minus x1 squared plus y2 minus y1 squared. I know this one here is square root of 500. Then if I square that, my x2, I'm going to consider point C as my x2 and y2. So that will be 3 minus k squared plus my y2 is negative 1 minus y1, that's 21, and I square that. Here, I'll get 500 is equal to 3 minus k squared. Then here, I'm going to get minus 22 squared. Right? There's no need to remove brackets here, as I told you yesterday. Simplify this. What is 22 squared? 400 what? 400 what? 484. Okay, you don't need to remove brackets here. You complicate the 484. Take the 484 to the left. If you do that, you get 16 equal to 3 minus k all squared. Then you take the square root on both sides, so you get plus or minus the square root of 16 is equal to the square root of 3 minus k all squared. Right? If you look at the mark allocation, it's 4 marks, which means you have to do a little bit of some working out for you to get full marks. Right? Then from here now, you get plus or minus 4 is equal to 3 minus k. Okay? Since we want to solve for k, my suggestion is take the minus k to the left and take the plus or minus 4 to the right. We do that, we get k equal to 3 plus or minus 4, which means k is going to be 7 or k is going to be negative 1. Right? But k is in the first quadrant, so we have to reject one of these two. And obviously, it's going to be this, the negative 1. Okay? Therefore, we can say k is equal to 7. And then you are done. Okay, so with all this working out, you get your full formula. Formula, right up, right up, right up, right up, right up, right up, right. It is possible that you might get a mark for the distance formula only or combined with the substitution. Okay, so you can get 1 mark here or 1 mark there, or you might not get a mark for the distance formula to be combined there. Then the substitution. In fact, the simplification here, I can give it. Okay, let's see. Simplifying there. I could give it, say, here. Give it there. Then I can give it there. Okay. Yeah. Maybe I will give it that way. Okay. And the rejection of that minus 1, it can also be given a mark. So I would say for now, I'll say that, but you must also consider the fact that the rejection of that minus 1 can be allocated a mark, depending on what the examiner wants. All right? So this is what you're supposed to have. Okay. Any question? Any question? No, sir. Right, let's move on to the next one. Right, 4.4. Now the question says determine the equation of the circle having center C and passing through point T. Write your answer in the form. Well, we have been doing this since last week, finding the equation of a right? To find the equation of a circle, we need the coordinates of the center. We also need the length of the radius. So for this question here, 4.4 is very easy because our radius is 10 units given, the center is given. So 4.4, the answer will be x minus 3 squared. I'm putting a minus here, but this minus is for the formula. The value of a, which is the x value at the center, is positive, plus y. Now the value of y at the center is negative, so it will be y plus 1 squared. And the radius is 10 units, so this will be 10 squared, like that. Okay, you leave it like this. Okay? Well, if you wanted to, I would suggest that at the bottom, as I said yesterday, then you can write, you can convert that 10 squared to 100. The general formula, you see the general formula, there is a minus here, there is a minus there. But if you look at the values here at the center, the x value, which is a, it's positive. That's why I put a positive 3 here. This minus here, it's a minus of the formula. You can see that there's a minus here. So this minus here, it's a minus of the formula. Again, there's a minus here between the y and the b. But the value of y, which is the value of b, it's a negative here. So if you put a negative b, that negative and the negative of the b value gives you what? A positive. Okay. To avoid confusion, because I can see that it's becoming an issue. All right, let me do it this way for the sake of some of you. Okay, so if I try to erase, I might end up removing my diagram. So let me do it at the bottom. Okay, so that's 10 squared. So let's substitute. Our A is equal to 3. B is equal to negative 1. Let's substitute into the equation of the circle. So I'll say x minus A is 3. So I'll put square plus y. There's a minus here, put the negative 1. Then you square. That's equal to 10 squared. So this will give you x minus 3 squared plus y plus minus and minus gives us a plus, and then you get that. Okay. So what I said yesterday, that's exactly what I did here. It's only that when I wrote this, I didn't show the working out. I did it in the head because it's 2 marks. There's no mark for the working out. The mark will be allocated for writing the equation correctly with the correct coordinates of the center and the correct radius. Following that. Yes, it is fine, but I don't want. Okay. All right. Then the next question, that's 4.5. Now, PS is a tangent to the circle at S and is parallel to the x-axis. What's the gradient of the x-axis? What is the gradient of the x-axis? It's a 0. I told you yesterday, or the day before yesterday, the gradient of the x-axis is 0, the gradient of the y-axis is undefined. You need to be aware of that. Determine the equation of PS. So we're going to determine the equation of PS. Okay? Now, to find the equation of PS, we obviously have a gradient which is 0. We need to know, remember the general equation of a straight line is y equal to mx plus c. So if the gradient is 0, means the equation becomes y equal to what? To c. So we need to know what is the value of y here. Okay? If we can find the value of y here too, it's the same as the value of y at that point. Okay? So, do we know, okay, do we know the value of x at this point? Yes. What is the value of x? At the point of contact here. Okay, I hope everyone you are aware that if PS is a tangent, it means it's perpendicular to the radius. And that radius is not drawn. So it will be like that. Okay? Right? So it means that PS is perpendicular to the radius, and that radius obviously originates from the center up to the point of contact. Now, if CS is perpendicular to PS, it therefore means that the value of x here is the same as the value of x at the center, and that will be a what? So all we have to do is determine the value of y at s by substituting the value of x at s into the equation of the circle. Okay? I'm going to repeat that. If our equation is this one here, because the gradient is 0 of the tangent, it means we need to find the y-intercept, which is a y value at this point here. The y value at the y-intercept is the same as the y value there. It's also the same as the y value here. Therefore, if you want to find the value of y at s, we have to substitute the x value at s into the equation of the circle, which is this one. So where there is x here, we are going to put what? 3 there. So that we can find what? y. Are you following that?
No.
Yes. Yes. Okay. Mandisa, do you agree with me that the gradient is 0 here? The equation is going to be that. Do you also agree with me that this c here is a y value? Then how are we going to get it? We are going to use the fact that the value of x at the center is the same as the value of x at point S. Why? Because the radius CS is perpendicular to the tangent PS. Therefore, we can calculate the value of y at point S by substituting the value of x into this equation. Okay? So when there is x here, we are going to put what? 3. Because we want to find a y value at s. So I'll substitute here, this is 4.4. So that will be 3 minus 3 squared plus y plus 1 squared equal to 100. This gives me 0, so I'm left with that. Y plus 1 squared is equal to 100. Then the square root of 100 is going to be 10. Okay, that will be plus or minus 10. Okay, then we take this one to the right. We end up having y equal to plus or minus 10 minus 1. Then we have y. If I take the positive, I'll get 9 here. If I take the negative, I'm going to get y equal to negative 11. Alright? Then, since I have two values, one is positive, the other one is negative, this point S is below the x-axis, therefore I have to reject the positive one. Okay? Point S is below the x-axis, so there's no way that y can be positive. I hope you're all aware that if a point is below the x-axis, means y is going to be negative. If it's above the x-axis, y is going to be positive. I hope you're aware of that. Okay? So it means our value of y is going to be equal to minus 11. And this will be the equation of the tangent. Okay. Our c is minus 11, therefore the equation of y equal to c is dy equal to minus 11. All right? Sorry? Yes. You have to show all the working out. All right. Can I carry on? Yes. Boys and girls, as I told you yesterday, maybe the day before as well, you have to know your analytical geometry if you are to make life easier for yourself when you write your maths paper too. Okay? Because the sequence of the topics is the start, the grade 12 starts, two persons on grade 10 and 11, 10, 11 and then 12, so two persons, 10 and 11 person and the grade 12 person. That's when it starts. Analytical geometry, two persons. Grade 10, 11 person and the grade 12 person. Then after the analytical, you come to three. Okay? Then the last topic will be your geometry. So if you don't know your analytical, you end up making things very difficult for yourself. Your heartbeat will increase in that next session. Fine. All right, 4.6 now. So the equation for PTR is given. So that's PTR, that's a tangent. It's given as that. Calculate the coordinates of P. Okay, now to calculate the coordinates of P here, it's not going to be difficult because since we are given the equation of this tangent here, PTR, we know the equation of PS and they intersect at a common point here, which means we can equate the two equations. So our two equations, 4.6.1, we are going to have two equations. The first equation is one that we are given 3y minus 4x equal to 35. Then the equation we got in the previous question, y equal to 11, sorry, minus 11. We are going to need that. Because the two tangents intersect at a common point means we can equate them. So we can equate there, or rather I would say we can substitute, maybe I can call this one here equation 1 and that one equation 2. So we can substitute equation 1 into equation 2, which is very simple. Which means it becomes 3 times minus 11 minus 4x equal to 35. This will give you minus 33 minus 4x equal to 35. And you get minus 4x equal to 68. Right? Okay? Then you divide both sides by minus 4x. Okay? Sorry, by minus 4 rather. Let me just remind you. Minus 4. So we get 68 over minus 4. And the x value will be minus 17. That's the y value. Or rather the x value. So the x value here, this point here, will be negative 17. Which is in line with the point where it is in terms of quadrants. That point, this point here is in the third quadrant. And in the third quadrant, x is negative. Okay? Once I get the x value, I want the coordinates of p. I know that the value of y here is equal to negative 11. Therefore, I'll say point p, x is minus 17, and y is negative 11. Okay. Right? So if you didn't do the homework, you disadvantage yourself because if you're the challenge with a question, right? At least if you did it, you will know that, okay, I didn't know how to do it because of this and that. It's always better to do the work or to try. Okay, so can I move on to 4.6.2? Now 4.6.2 says, calculate giving a reason the length of PT. So the length of PT is from this point to that point. All right. Now, to calculate PT, it's going to be very easy. We can use the theorem of Pythagoras. That's the easiest. But before we use the theorem of Pythagoras, we need to determine the length of PC. Okay? We need to find the length of PC. Because we know that CPT is a right angle triangle. The length of TC we know is 10. We want to calculate PT, we don't have it. But we have the coordinates of P and the coordinates of C, so we can use the distance formula to calculate the length of PC. Once you get the length of PC, then the theorem of Pythagoras kicks in and then we utilize it to get the answer. So it's not very difficult. Okay, so let me move on to the next page. So on the next page, I'm going to calculate the length of PC. So this is 4.6.2. PC squared is going to be equal to y2 minus y1 squared, or rather, sorry, I can write this x2 minus x1 squared plus y2 minus y1 squared. Right? So at the center, my x is a 3 minus 17 squared plus minus 1 minus 11 squared. Okay? So this will give me 20 squared plus 10 squared. So I need to find that sum. This will give me 500, which means my PC is going to be equal to the square root of 500, which is 10 square root of 5. Now this is interesting because we calculated the distance earlier of RC, and we got this as well. Which means that for me to calculate the length of PT, right, I'm going to have more than one way of doing it, but I'm going to use the theorem of Pythagoras. I don't want to stress myself. Okay? So, to go back here, I'll say in triangle CPT, okay, in triangle CPT, right, we're going to have PC squared is going to be equal to PT squared plus TC squared. That's Pythagoras. Alright, this is the theorem of Pythagoras. The square of the hypotenuse is equal to the sum of the squares of the other two sides. Right? I know that some teachers they teach this way, but they're going to calculate the length of PT. They put the PT on the left, then this PC goes on the right, then you end up having PT squared being equal to PC squared minus TC squared. That's not the theorem of Pythagoras. The theorem of Pythagoras is what a plus. From the definition of the theorem of Pythagoras. Right? So, from here, we substitute now. So, PC is the square root of 500. Then I'll square that. Right? PT is the one that I want. So that will be PT squared plus 10 squared. So here I'll get 500 equal to PT squared plus 100. If you take the 100 to the left, you get 400 equal to PT squared. You find the square root of 400, which is very straightforward. Okay, you get 20 PT. And then that's it. Okay. Right. So this is what you're supposed to do. And it's coming back very soon. It will come back very soon. Right. And last question I think before we go. Alright. 4.7.1, write down the coordinates of the center. The coordinates of the center. There's a minus there, there's a plus there, which means the x value at the center is positive, the y value is negative. So that's 4.1, 4.7.1, 4.7.2. We want the radius, the length of the radius. So our radius is equal to the square root of 16, which is 4 units. So this is very straightforward. Okay? Then 4.7.3 says prove that the circle with center C. Now, the one that says center C is the one in the diagram. And the circle with center M do not intersect. Okay? So I'm going to do it the way that I did it yesterday. I did the other question yesterday. where I'll calculate the distance between the two centers first, get the sum of the radii, and then interpret it after that. Right. So 4.7.3. So calculate the distance between the two centers, going to be D equal to, if I choose the coordinates of the center of that one, then it's going to be 3 minus 3 squared, which means they have the same center. Okay, do you see that? Plus that minus 1 there, minus 16. This is going to be interesting. So this will be D equal to, that will be positive 15 squared. So it means D is going to be 15 units. Okay? So D is 15 units. Then my R1 is, if I consider the radius for point T, for circle C, is going to be 10. My R2 is going to be a 4. Now, R1 plus R2 is going to be 10 plus 4, which gives you 14 units. Okay, now we need to interpret this. The distance between the centers is greater than the sum of the radii. Okay, but their center is the same. Okay, the center is what? It's the same. So how do you interpret it? Their center is not the same, but the x value at the center is the same. Okay? The x value at the center is the same, but the y value is not the same. This will be minus 16 is going to be at the bottom here. Right? So we are going to have the center somewhere at the bottom, where x is 3, but y is going to be negative 16. Now, the conclusion there will be, since D is greater than the sum of the two radii, we say the two don't intersect. D is greater than R1 plus R2. Okay? Therefore, the circles don't intersect or touch. Okay. Now, before you write your math paper 2, even your June paper as well, in the trial examination, you need to make sure that you go over your intersecting circles, just in case the question comes on that. Okay. So this is what you're supposed to have done.